Hello, in this tutorial we're going to look at stream mutations. So Zen was designed for pattern interference, and here in this example I want to take two streams, stream 0 and stream 1. I want to define some causal relationships between different musical parameters, and then I want to let them go and see what happens when they interfere with each other. So there's a bit of boilerplate code here. I'm taking stream 0 and stream 1, and I'm saying they should both be instrument 0, should cut themselves off, a little bit of reverb. And stream 1, I'm saying it should last for 4 beats. So we could write this as out in milliseconds. Anywhere you specify time in Zen is always in milliseconds. But if you want to map milliseconds to beats, you can do this little global function. So let's say it lasts for 4 beats. In stream 1, I've pitched it down an octave so we can hear the difference. And then just so we can see a bit more easily what's going on with each stream, I've said each of them should move from left to right across the canvas once per cycle, and stream 1 should be placed halfway down the canvas. So let's just watch that run, and we can see each stream moving from left to right once per cycle. Okay, so what we're going to do is say stream 0, I'm going to trigger an event every cycle, so every 16 divisions. Let's see what that sounds like. Okay, I'd like to start manipulating some of its parameters. So I'm going to use .p, which holds all the different parameters that are going to get passed to the instrument. And I'm going to use the mod I for modulation index. And I'm going to say it should run from 0 to 10 over 1 cycle. So let's hear that again. So there's no change in sound because at the point that we trigger an event, which is here on the canvas, it's at the 0 part of the saw function. What we'd really like to see is that it smoothly mutates from 0 to 10 as we go across each cycle. So for that, we're going to need to introduce a new stream parameter, and that's s stream, or s0 in this case, .m for mutate. And this behaves in exactly the same way as .e. It's expecting patterns of 1s and 0s. When it's a 1, it will trigger a mutation, and when it's 0, it will be ignored. So let's keep it simple and say I want to trigger a mutation on every single division. And there's one final thing. Any parameter that you want to mutate, to be mutable, you need to prefix with an underscore. So now this should trigger a mutation on every division of the bar and smoothly move from 0 to 10 as we go across the canvas. Very nice, but I can hear some the steps between divisions. So for this, we need to introduce the lag parameter, which says how long each mutation should take to kind of smoothly ramp to its new value. So as with any parameter that's expecting time, I could use milliseconds, or I could again say I want you to take half a beat. So now we are smoothly mutating from 0 to 10 across a cycle. Let's introduce another parameter here. Let's use the harmonicity. Let's go from 1 to 5 and see what that sounds like. So any parameter can be set to be mutable, and anytime you trigger a mutation, it will smoothly ramp to whatever value it's at in its particular life cycle of whatever you've applied here. So this is all well and good, but because we want to get patterns or streams to interfere with each other, why don't we set this to use another parameter from another stream? So let's do s1.e. Let's do every 8 and not s0.e. So we should hear that now triggering somewhere around here. setting this to mutate on every division, why don't we say you should mutate every time stream 1 triggers an event. Let's make this a bit longer, shall we? See what happens here. So there we go, some basic pattern interference between streams using the mutation parameter. As ever, if you go to the documentation and have a look in mutations, there's a bit of a summary of what I've discussed here, and there's some sample code here to kind of get you exploring how different ways of using it. Enjoy!